So let's take a look at this limit as x approaches 4 of the quantity 4 minus x over the quantity square root of x minus 2. If we use the quotient rule, we see we have the limit as x approaches 4 of 4 minus x over the limit as x approaches 4 of square root of x minus 2. Now remember, what we're trying to accomplish here is to understand how this original function behaves as x gets closer and closer and closer to 4, both from the left and from the right. So what we've done is now we're focusing on how does the numerator behave as x approaches 4 from both the left and the right, and how does the denominator behave as x approaches 4 from the left and from the right. Well, as x approaches 4, 4 minus x will approach 4 minus 4. And as x approaches 4, square root of x will approach square root of 4 minus 2. Numerator simplifies to 0. Denominator simplifies to 0 as well. So we have an indeterminate form. Determinate form. So we need to use some algebra to help us write this function in a different form. So create an equivalent representation of the function, one that allows us to evaluate this limit. So the tool that we're going to use is the conjugate. So given an expression, let's say a plus b, the conjugate of that, just a quick reminder, is a minus b. So we're going to, and vice versa. So if I was given a minus b, then my conjugate would be a plus b. So we're going to use this conjugate as a tool to help us evaluate the behavior of this function as x approaches 4. So let's go ahead and multiply this function by the conjugate both in the numerator and the denominator. And we're going to use the conjugate of the denominator. We're going to try to remove that 0 in the denominator. And by removing that 0 that we saw, hopefully the numerator will work out for us. So we have 4 minus x over square root of x minus 2. So we're wanting to know how that function behaves. So we're going to multiply by the conjugate of the denominator, so square root of x plus 2, and we're going to do that to both the denominator and the numerator. So in doing that, we're not really changing the function itself, we're just multiplying by a cleverly disguised number 1. That will just change the function to an equivalent form. So when we do that, we have the limit as x approaches 4. In my numerator, I will have 4 minus x times square root of x plus 2. And we're going to hold off multiplying that. In my denominator, if I multiply those, I get the square root of x squared plus 2 square roots of x minus 2 square roots of x plus, nope, that's minus 2 squared, or 4. Okay, so let's go ahead and simplify this denominator a little bit. So we get the limit as x approaches 4 of 4 minus x times the square root of x plus 2 all over. Now, I notice I have plus 2 square roots of x and minus 2 square roots of x. So those add to 0. And that leaves me with square root of x squared, so that's x minus 4 as my denominator. Now, we might be tempted to say that 4 minus x and x minus 4 simplify to 1, and they don't because the signs are opposite. So what we can do is we can factor out a negative 1. So I'm going to factor out my negative 1. So I get the limit as x approaches 4. My numerator, I will have negative 1 times x minus 4 times square root of x plus 2 over, my denominator will be x minus 4. Now my factors of x minus 4 in the numerator and denominator are the same. I can simplify them. And so what we're left with is the limit as x approaches 4 of negative 1 times the square root of x plus 2. So through this algebraic process of creating an equivalent function, what we're saying is that negative 1 times the square root of x plus 2, that function behaves similar to the original function as x approaches 4. So then, as x approaches 4, we'll still have our factor of negative 1. Square root of x will approach square root of 4. And 2 will, as x approaches 2, 2 remains 2. So 2. And so 2 plus 2 is 4 times negative 1 is negative 4. So what this means is that as x approaches 4, the function 4 minus x over square root of x minus 2 approaches the y value of negative 4. So now let's take a look at the limit as x approaches 0 of the quantity x square root of x plus 1 minus 1 in the numerator and x in the denominator. So if we imagine x getting closer and closer to 0, then this square root of x plus 1 gets closer and closer to the square root of 1. And the square root of 1 is 1, and 1 minus 1 is 0. So our numerator approaches 0 as x approaches 0. Also, our denominator has only the x variable in it, and so it approaches 0 as well. So we have an indeterminate form of 0 over 0. So let's go ahead and use the conjugate to help us find the limit of this particular function. So we're going to take the limit as x approaches 0. We have our original function, in the numerator square root of x plus 1 minus 1, and in our denominator just the x. And now we're going to multiply by the conjugate of the numerator in this case. So we're going to have the square root of x plus 1 plus 1 over the square root of x plus 1 plus 1. And that's our clever number 1 that we're multiplying by in order to resolve this indeterminate form. So when we do that, we end up with the limit as x approaches 0. And using the distributive property, well, first let's do this. So we'll have square root x plus 1 minus 1 times square root x plus 1 plus 1 in our numerator. And in our denominator, we'll have x times square root x plus 1 plus 1. So now, if we simplify what's in our numerator, we get the limit as x approaches 0. Using the distributive property to multiply my numerator out, we end up with the square root of x plus 1 squared plus the square root of x plus 1 minus the square root of x plus 1 minus 1. And in my denominator I have x times the quantity square root of x plus 1 plus 1. And I'm not going to multiply out my denominator yet. I will wait until at some point it becomes necessary to do so. So what I notice is in my numerator I have a plus square root of x plus 1 and a minus square root of x plus 1. So those sum to 0. So now my limit is x approaches 0 is, also notice that here we have the square root of x plus 1 and then we're squaring it. So this will just become x plus 1. When I square the square root of something, I get that quantity that was under the square root, and then I have a minus 1. And then in my denominator, x times the quantity square root of x plus 1 plus 1. Now at this point, I can see that I'm going to have a plus 1 and a minus 1. Those are going to sum to 0. And what I'll be left with in my numerator is simply an x. Now that x that I have left over in my numerator, I can simplify with my denominator. They will divide out and become a 1. So at this point, I have the limit as x approaches 0 of 1 over the square root of x plus 1 plus 1. Now, as x heads to 0, my numerator remains 1. And as x gets closer and closer to 0, this square root of x plus 1 gets closer and closer to the square root of 0 plus 1, or the square root of 1. So I have something like square root of 1 plus 1. And of course, the square root of 1 is 1, and 1 plus 1 is 2. So this limit is 1/2. I hope you find this helpful.